Hi everyone. In this lesson we want to learn how to multiply and divide complex numbers. Now again, you shouldn't think of complex numbers as being complicated because they're really not. They're actually pretty straightforward and easy. And all you have to do when you add, subtract, multiply, or divide complex numbers is just treat the I like a variable. And in this case, if you ever end up with an I squared, remember I squared is equal to a negative 1, so you get to simplify that. So if I multiply 2 plus 5i times 3 minus I, that's just two binomials. I'm just going to FOIL those together. Multiply 2 times 3 gives you 6. That's your first ones. Do the outer ones, are a negative 2i. Do the inner ones, would give you plus 15i. And then do the last ones, 5i times negative I, that would be a negative 5i squared. Now, I got an I squared right here. I can trade that in for a negative 1. And then I can, of course, combine these middle terms. So I get 6 plus 13i, and minus 5 times minus 1 is plus 5, so I can combine this with the 6, so I might get 11 plus 13i. Well, it is kind of interesting if you think about it. If you multiply a complex number by another complex number, it turns out you'll always get a complex number. You'll always be able to do this process. You'll get an I squared, and the I squared will become a negative 1, and you'll be able to simplify it down to another complex number. So this complex number times this complex number is this complex number. We can also square complex numbers just like we square other numbers, and you do just like you would expect. To square a binomial just means to multiply it by itself. So again, if you multiply all that out, you'd get 9, right? Or you just square the 3 and get 9, and then take the 3 times the 2i and double it. That'll give you 12i. That's the same thing as doing the outer 6i, and the inner is another 6i. And then 2i squared would be 4 times I squared. That's a 2i times a 2i. Again, you have an I squared, so you can trade that in for a negative 1. And so this is going to give you 9 here, and then 4 times negative 1 is negative 4, so that's 5 plus 12i. So if I square this complex number, I get this other complex number. All right, so how about if I multiply 3 minus 4i times 3 plus 4i? You should notice this is one of the special products that the middle terms are going to cancel. 3 times 3 is 9, and then the 12i from the outer terms and the negative 12i from the inner terms cancels, and you just get minus 16i squared. So notice in this case, because there's no middle term, all the i's are going to disappear. And I'm going to end up with 9 plus 16 is 25. Okay? Well, we call these conjugates, and because they're complex numbers, we call them complex conjugates. And that's a term you'll want to remember. And the conjugate of, for example, a plus bi is just a minus bi. It's the number you'd multiply by in order to have these i's all cancel out and give you the real number. All right? Well, let's go on and talk about dividing complex numbers. Suppose I wanted to divide 6 by 2 plus I. Well, the way we divide these isn't like our long division, like we think of dividing real numbers. It's really more like rationalizing denominators. What I'm going to do is I'm going to multiply this denominator by its conjugate, 2 minus I, and I'll do the same thing in the numerator, 2 minus I. That doesn't seem much like a division process. Like I say, it's more like rationalizing denominators when we had radicals here. If I had like the square root of 3 plus 1, I'd multiply by the square root of 3 minus 1, and that would rationalize the denominator. Well, you can sort of think of that like that. We'd have to call it realifying the denominator instead of rationalizing the denominator, though. And so this is going to give me 6 times 2 minus I in the numerator, and I may want to multiply that out here in just a minute. We'll see. And then in the denominator, I'm going to get 4 minus I squared. And again, you get to trade in the I squared for a negative 1. Now that's going to give me 5, and once I see this is 5, I see the 5 is not going to divide into the 6, so I might as well just go ahead and distribute that 6. So that's going to give me 12 minus 6i in the numerator all over 5. And notice that I can now rewrite this as 12 fifths plus a negative 6/5 I. So if I take this complex number, remember every real number is also a complex number, and I divide it by this complex number, I get this complex number. I get 12/5 plus a negative 6/5 I. All right? And I probably would, instead of writing plus a minus like that, I'd probably just put a minus right here. That's probably the easiest way to do that. Okay? All right, so if I wanted to divide this complex number, 5 minus 2i, by 3 plus 6i, again, I'm just going to multiply by the complex conjugate of the denominator, because I really want to get rid of the i's in the denominator, so I'll multiply by 3 minus 6i over 3 minus 6i. And then I'm going to have to multiply out all the numerator. That's going to give me a little more. I'm going to get 15. And then I'd get a negative 30i and a negative 6i. That's negative 36i. And then I'll get plus 12i squared. I'll get to trade that I squared in for a negative 1 here. I'll write that in a minute. But in the denominator, I've got 9 minus 36i squared. I don't even have to worry about the outers and inners because I know they're going to cancel. So I just write, 9 and then minus the 36i squared. Okay, let's trade in those I squareds for negative 1s. And then I can simplify. So this is going to equal, I'm going to get 15 minus 12 here, so that's 3 minus 36i. And the bottom, I'm going to get 9 plus 36, that's 45. So notice I could write that as 3 45ths minus 36 45ths I. And I can simplify that, of course. That's 1 15th minus, let's see, 9 goes into each one of those, 4/5 I. So if I take this complex number, 5 minus 2i, divide it by this complex number, 3 plus 6i, by multiplying by the conjugate of the denominator, then I will end up with this complex number, 1 15th minus 4/15 I. Now I'd also bring to your attention that your graphing calculator, if you have one, typically is able to do these computations on it. On the TI-83 or 84, there is an I button right above the decimal point down here. So if I were to divide these, I'd want to be sure and use a parenthesis. 5 minus 2i. Okay, there's my numerator. Divide by, again, put parentheses around the whole denominator, 3 plus 6i. And when I divide that, it gives me 0.066, gives me as a decimal, right? But I have this wonderful frac button under the math menu, and that gives me 1 15th minus 4/15 I. So that checks. Okay?